Learning how to build projects is really hard, which is why in this video, I'm not only going to show you how to build out a Minesweeper clone, but I'm also going to break it down step by step exactly what I'm doing, my thought process, and why I do different things. That way you can actually learn how to build projects on your own. And this video actually comes straight from my JavaScript Simplified course. If you're interested in taking your JavaScript skills to the next level, learning how to connect the dots, and really start building projects on your own, you're definitely going to want to check out that course. It'll be linked down in the description below. And if you use the code early, you're going to get 20% off, but that's only good for the next couple of days, so make sure you take advantage of that if you're interested. If you go down in the description of this video, you're going to see that I have the before code linked. It's just a really simple HTML file and a CSS file that contains all of the code that you're going to need. And really the only important thing to note about this CSS file, if you scroll all the way down here, the section down here where we have data status, hidden, mine, number, and marked, these are statuses that you need to apply to the different grid tiles in order to give them their specific styles. So hidden is going to give you a tile that looks like this. If you right click on a tile, it'll mark it, which is this marked style. If you click on a tile and it's a mine, it's going to give you this red style here. And if we refresh so that we actually have a fresh game and we click on a tile, as you can see, a tile that has a number on it is going to have the number style applied to it. So that's what these different styles are. That's pretty much the only thing in the CSS that you need to be aware of. Also, I want to kind of go over the rules of Minesweeper so that you're familiar with them. Whenever we mark a tile, this mine's left number is going to decrement, and it's okay if this number goes negative. As you can see, if I mark more than 10, it's going to go negative. That is perfectly okay. And if you mark a tile, you can't click on it with left click. So to mark a tile, you right click on it, and to open up a tile and reveal it, you left click on it. And essentially, if we can find here a open space, I didn't find any there, so let's just refresh. If we click on a space where there's adjacent tiles next to it that are all empty, then it'll reveal all of those tiles to you. And essentially the way Minesweeper works is there's a specific number of mines, in our case 10 is the default we're using, and every number tells you how many tiles, or how many mines, I'm sorry, are next to this in the 3x3 grid around it. So including diagonals. So this 1 means that there's 1 mine adjacent to this 1, which in our case is this tile here. This 2 means that there's 2 mines adjacent to it, so it could be any of those including the diagonals, and so on. So, we could mark here, we could mark here, we could mark here, open these up, and so on. So that's essentially how Minesweeper works. And the goal of the game is if you clear out all of the tiles, so if we just kind of go through here and we clear out all the tiles, just imagine that we actually won the game. It'll say that we won, and then we can refresh to restart. Or if we click on a tile that, for example, is a red tile, a mine, then it'll reveal all the mines to us and it'll tell us we lose and we can't click on anything else. So we just have to refresh and start over again. And that right there is all the knowledge you need in order to build out this Minesweeper game yourself. So if you want to, you can try to build this out yourself, but if you feel like you get stuck at all, you can just come back and watch this video at any point, and at the very beginning of this video, I'm going to explain my thought process of how I get started building this Minesweeper game. I'm just going to create a really simple script.js file for our JavaScript, and in here I'm just going to start writing a bunch of comments describing exactly how I think this game is going to work. So the first thing we need to do is populate the board, because as you can see, our board is empty. There's no tiles inside of our board. So number one, we need to populate a board with tiles / mines. That's obviously the first thing that we need to do. And then once we have a board, we need to be able to left click and right click on tiles. So we need to be able to left click on tiles, right click on tiles. That's pretty self-explanatory. And going along with these lines, if we just kind of go with left clicking on a tile, this is going to reveal to us. So we could say reveal tiles. And by right clicking on a tile, we're essentially marking a tile. So we need to be able to mark tiles as well. Finally, kind of the last thing that we need to do here is we need to be able to check for win/loss. We just need to see, did you win? Did you lose? And we also need to be able to check that constantly, because as soon as we click on a bad tile or we finish up clicking on all the tiles, then we know that we've either won or lost, and we want to be able to show a message telling them. Also, before we get started, I kind of want to think about the logic of this actual game and how to structure the code. There's kind of two parts to this game. There's the logic behind the scenes of like checking tiles that are adjacent to figure out what number these things are, checking if it's a mine, if it's not a mine. All of this logic portion is one part of the game. And then the other part of the game is the actual display of the game itself, which, is giving us the colors and the numbers on the screen and the ability to left click and right click. So I kind of want to separate these two different sections, like the game logic itself from the actual display of the game. I'm going to create a separate file, which I just call minesweeper.js. And this is where I'm going to put all of the logic. So I'm just going to say logic in here. And this script.js file, if we just move this down a little bit, this is going to be for all of the display or like the UI. So that way our UI is separated from the actual logic of the game. This just makes it easier to write our code, easier to test our code, and so on. So if we go back to the script, we can kind of see that the very first step is going to be to create a board with tiles and mines. And this is two parts. There's a logic portion, and then there's actually a display portion for showing the board. The first part, the logic part, is just creating the board. So we can do that in this Minesweeper class. Let's just create a function called create board. And this is going to take the board size because we need to know how big our board is. It's a square, so we just need to know one direction. And then we want to have the number of mines. These are things that we can configure when we create the board because we need to know how many mines to put on the board and also how big our board overall is going to be. Now the way that we're going to create this board is actually going to be an array of arrays. So let's just come down here and say const board is equal to an empty array. And this is going to be the start of our board. And each row in our board is another array. So you can kind of imagine if we had a 2x2 board, we could have something that looks like this. You know, a 1 would represent a mine and a 0 would represent not a mine. In this very simplified case, but you can see we have an array of arrays where each entry in the board array is a row and each entry in the row is a cell from left to right. So the actual board array looks very similar to the board on screen, which will just make it easier to work with everything that's going on. So by default, our board is going to be empty. And then for each row, in our case, each board size, we need to loop through that. So we can just say for let x, because this is our x direction, equals 0, and x is less than the size of our board. What we need to do is just add 1 to x. So a very simple for loop, and we also need to loop through the y direction. So I'm going to copy this for loop, but this time we're going to do the y direction here. So make sure all of this is y, and since we have a perfect square, we can use board size for both of these. Then for every single x, I want to create a new row. So we can say row is equal to an empty array. And then inside of here, I want to create a new tile. So we can just say const tile is equal to an object. And we know this object is going to have an x and a y property. And we can use that shorthand notation to specify our x and y. And then we could just say row.push tile. And for now, that gives us a board if we make sure here that we push our row into our board. So if we kind of condense this for loop, you can see we loop over all of our rows, we create our row, and then we add our row to the board. And then here what we're doing is we're creating each tile and adding that into our row for this inner for loop. And then finally at the bottom, just return our board. And if we export this function so that we can use it inside of our script here, we can just say at the top, import create board from, and we want to get it from minesweeper.js. Make sure that's a period there. And we can just say console.log create board, and let's just say we're going to do a 2x2 board, something very simple to get started with. And now all we need to do is make sure we include a script tag that is going to be to script.js, and the type is equal to module. So now if we just inspect our page over here, we should have that board printed out to the console. As you can see, we have an array, 2 wide, and another array inside of each of those, which is 2 wide. And as you can see, this first one has x0, y0, x0, y1, and x1, y0, x1, y1. So we've essentially created a grid that's 2x2 that fills up all of this available space. Now the next thing that we need to do back in our Minesweeper here is actually give us an element that we can display on our screen. We need to be able to display a tile on our screen. So let's create that element. And this element very simply is just document.create element, and we're just going to use a simple div. And now if you remember when I talked about the CSS down here at the bottom, we have our different statuses, hidden, mine, number, and marked. Well, I want to create those statuses inside of a const variable. So we can just say const tile statuses is equal to, and remember we have different styles. We have here hidden, mine, number, marked. So hidden is going to be equal to the text hidden, and this text here is just matching up to the text in our CSS. Then we're going to have mine is equal to mine, number equal to number, and finally marked is equal to, mark. And let's make sure this is actually called marked, so we'll say marked. There we go, so we have our different statuses, and by default all of our elements are hidden, so we can just say element.dataset.status is going to be equal to tile_statuses.hidden. By default we want to make this hidden, and we can just add that element to our tile. So now what happens is if we just fix up the little spacing here, save this, make sure we inspect our page, we go over to our console, you can see that we now have this element, which is a div, and this div, if we go all the way to the dataset property, here has a status of hidden, which is going to make it show up hidden when we put it on our grid. So obviously the next step is to add it to our grid. Inside the script here, let's just put this inside of a variable. And we also need to be able to get the board from our HTML, which has here a class of board. So what we can just do is say const board element equals document dot get, or I will say just query selector of dot board. And now we can add each one of these board elements to this board. So we need to loop through our board. So we can say board dot for each row. And then for each row, we need to loop through that to get the individual tiles because we have a multi-level array. And then we can say board element dot append tile dot element because that's the element that we created inside this Minesweeper here. So if we save this, you can see that we have these elements being appended to our grid. They're very small right now though. The reason these are so small is actually because of another thing in our CSS. If we scroll up here a ways, you'll notice that our board is determined by this size variable, and this size variable is currently not set. We need to set this size CSS variable inside of our JavaScript, and right now our board is 2 by 2. We've manually set that. Let's just create some variables called board size, which we'll set to 2, and const number of mines, which we're going to set to 2, because that's what we're using here. We can say board size and number of mines. That way we have these two default variables. And then on our board element, we can say board element dot style. And all we need to do is just set property. And that property is called -- size. We want to set it equal to our board size. That essentially tells us that we have a 2 by 2 grid. And if we change this to be 4, for example, we've now created a 4 by 4 grid. Or if we bump it all the way up to 10, we now have a 10 by 10 grid on our screen, just like we do in this example here. I just want to clean this up a little bit, so we're going to move some spacing. We'll put our style down here below. So this is just setting up our board. This is setting up our board. This is getting some variables. This is our constant variables. Everything still works. And now over here, we need to add some additional functionality to our tile, because when we click on a tile, right click or left click, we need to change the status of that tile. And right now we have to set the element.dataset.status, which is kind of a pain. It's not the most easy way. So let's just create a getter for our status. And this is just going to return our element.dataset.status. And let's do a setter as well. So we could just say set status, which is going to take in a value. And we just want to return this, I'm sorry, not return. We want to take this element.dataset.status. And we want to set it equal to that value. And here we just need to make sure we use this. So now we can actually get and set the status of our tile directly without having to go through this element.dataset.status, mumbo jumbo. That's just kind of a lot. So now if we just inspect over here and we go to our console, make sure that we're logging out our board, just like this, and we just look at one of our random tiles, you can see if we click on status, it's going to print out hidden because it's getting that from our element.dataset right here, .status. It's doing that all for us. The next thing to do is to actually populate our board with all of the different mines. Right now, we're not doing anything with our mines. So the way I want to do this is with a property on our tile called mine, which will be true, or it'll be false, depending on if it is a mine or not. But for now, let's just manually set this to true. We're going to do this in a little bit, actually make this correct. But what I want to do is generate where our mines are going to go with this number of mines. So we can say const mine positions is equal to a function we're going to create called get mine positions. And it's going to take in our board size and the number of mines. So essentially all this function is going to do is give us 10 random locations, or actually in our case, 2 random locations based on this number of mines inside of our board that are going to be mines. So it's going to give us an array of values. And this array of values is essentially just XY coordinates, which we're going to match up with these XY coordinates here. So let's create this get mine positions function. Function get mine positions takes board size and number of mines. And in here, let's just create a variable called positions, set it to an empty array. And then at the bottom, we're going to return those positions. And in here is where we're going to put all of our mine positions. And you may think it's smart to just say, let's create a loop. We'll say let I equal 0, I is less than number of mines, I plus plus. And you may think, okay, inside of here, we'll just generate some random numbers and put all of our mines inside of this array. But the problem is that when you generate those random numbers, maybe you get x equals 1, and y equals 2 for the first mine, and then it keeps going 3rd, 4th, 5th, 6th, 7th, and all of a sudden you get another mine that's x equals 1 and y equals 2. So they're in the exact same location. This would be a problem because then you would have two overlapping entities, and we don't want that. And we would have no way to know because we're just inside of a for loop. So instead, I'm going to be using a while loop. And I'm going to check the length of our positions, and while it's less than the number of mines that we want, I want to continue to loop. That way, if for some reason we accidentally have a mine that gets generated on the same position as an already existing mine, we're just going to continue going through our while loop over and over and over again. So let's just create a position. And this position is going to have an x, and it's going to have a y, and these are going to use a function called random number, which we're just going to generate. And it's going to give us a random number between 0 and the size of our element, which is our board size. So let's create that function random number, and it's going to take a size. And for now, let's not worry about this function. Let's just assume that it works. And what we need to do is we need to check, does this position already exist inside of here? So we can say positions.sum. This will return to us true if at least one of the elements in this array matches the thing. And we need to create a new function to match position. We're going to call that position match. So let's create that function. Just like that, position match. And this function is going to essentially take two different positions, a position A and a position B, and we want to check to see if they have the same coordinates. So we're going to say a.x is equal to b.x, and the a.y is equal to b.y. If both of these are true, then they're exactly the same position, so we can return true from position match. So up here, we could say for each position, which in our case, we're just going to abbreviate position to P. For each position, we want to check if P and position are a match. If they are not a match, we'll put the double exclamation in the front here. So if they're not a match, then we're going to add this position to our array. So we'll just push the position to our array. And this is why we're using the while loop, because if they already exist, we're just going to skip the adding step and continue running through this while loop until we get one that's not a repeat. And also, we can use bind to simplify this code right here a little bit. So instead of calling position match with position every single time, we can say that we want to take position match.bind. We don't care what this is, so we'll just pass in null. And we want to bind the position to A. So A will always be our position, and then whatever each iteration of our loop through of positions will be is going to be passed in as B. So this is just another way to write that code. Either way works, it doesn't really matter. Now let's write this random number function. Inside of here, we just want to get a random number with math.random, multiply it by our size, and then in order to make sure this is an integer, we can just say math.floor. This is going to convert this to an integer. And now, if we scroll all the way up here, we should have some positions, and we can just log them out. Mine positions. And let's make sure we don't have any other logs anywhere, so let's inspect our page. Go to our console, and now we have an array with two elements, x3, y9, x6, y8. If we just refresh, you can see that we now get x6, y1, x4, y1. So it's just completely random. And if we change this to be 10 mines, for example, now you can see that we have 10 different elements in this array. So now the final thing that we need to do inside this Minesweeper function is actually set the mine. So if our mine positions dot sum, again, we're just checking to see if at least one of these matches. So we want to do that position match, and we can do that same bind trick again. So we'll say bind null, and we're going to pass in here our x and y coordinates for our current element. So all this is doing essentially is it's saying, okay, check to see if the positions in our mine positions, if one of them matches our current x and y coordinates. That's all that this code is doing. If the x and y coordinates of our current tile are in the mine positions, then we know this is a mine, so we return true. Otherwise, we return false. And now, all the way over here, if we just console log our board, we should be able to find some tiles that have mine set to true. So let's go to the console, open this up, and you can see inside of here, if I just expand this, all of these are false. We go down to this one, all of these are false. And as you can see here, we have two mines that are true. So randomly, there will be 10, set to true throughout all of these different arrays, and it's completely random because we have that randomness set up for all of our functions. So right here with all of this code, we've essentially completed step one. We populated a board with tiles. We have this board variable here, as well as a visual representation of it. And we also put in all of the mines that we need based on this number of mines. Really, the last thing left to do is make this mines left text actually show up properly. So let's just set this to 2 for now so we can see the difference in our text. And if we go over to our index.html, you can see right here is where our text is. Let's just create a span that we can put the 10 inside of. And we can just give it whatever we want. We could say like data mine count. And then inside of our code here, we can say const mine count. We'll actually say mines left. There we go. Text is equal to document.query selector. And this is going to be for mine count. And then our mines left text here, we can just set equal to our number of mines. And of course, that didn't quite work. So let's make sure we got this right. Mine count, it should be data mine count. And again, of course, this mines left text, we need to make sure we set the text content of it. There we go. We've changed our mine left to 2. And if we put this back to 10, this will change to 10, which means in our index, we don't even need a number here at all. There we go. It's just populating for us inside the JavaScript. Now, the next thing that we need to do inside of our script is steps 2 and 3. Let me make sure these are indented a little bit so we know what they go with. Step 2 is figuring out left clicks, and step 3 is figuring out right clicks. Luckily, this is actually pretty straightforward. We can say tile.element, and we want to add an event listener for click. This is going to handle our left clicks for us. And when we want to handle right clicks, we can't use click because this is only for left clicks, but for right clicks, we can say tile.element.add event listener for context menu. Context menu is what happens whenever you right click. And in order to make sure that right click menu like this doesn't show up, we can just say e.prevent default. And now if I save this and right click on a tile, it doesn't actually do anything. It doesn't pop up this menu. So if I right click on any of these tiles, we're preventing that default. So essentially we were handling left clicks and right clicks, so we can kind of remove this. Now all we have left is revealing and marking and checking for win loss, which is pretty much the bulk of everything. So it may seem like a small list, but this is actually quite a bit. We're actually going to start with marking tiles. It may seem like a great idea to start with revealing because that's kind of the main concept of the game, but marking tiles is significantly easier and will give us a great head start. So inside of this context menu event listener, what we need to do is call a function to mark these tiles. And I want to define this on our Minesweeper object because this is actually going to be the logic for the game. So we can just say mark tile is going to be a function that we create on that Minesweeper. And in here, we just call mark tile. We pass it in the tile that we want to mark. So now inside of Minesweeper here, we can create that function. Export function mark tile, and it's going to take in a tile that we want to mark. Now the very first thing we want to do inside this mark tile function is just check to see if the tile we're marking is eligible to be marked, because we can only mark a tile that's hidden, or we can unmark a tile that's already marked. So we need to make sure we just check here if the tile.status is not equal to hidden, and the tile.status is not equal to marked, so we can just say tile_status.marked, then we just want to return. So essentially here we're just checking, is the tile hidden or is the tile marked? If it's either hidden or marked, continue on. Otherwise, we're just going to return prematurely, because if it's not hidden and it's not marked, then it means that it's either a mine already revealed or it's a tile that we've already revealed and it's a number tile. So we don't want to be able to mark something that's already been revealed. Then down here, we just need to be able to check, are we marking it for the first time or are we unmarking it? So if the tile.status is equal to tile_status.marked, this means we need to unmark the tile. So we can say tile_status is going to be equal to hidden because we're unmarking it. Otherwise, what we need to do is just take our tile.status and we need to set it to our tile_status.marked because now we're marking this tile. And that should be all of the code that we need to write. Now, if we right click on a tile, you can see that it turns yellow. And if we right click on it again, it removes that marked syntax. So we're able to mark all of these different tiles. And that's just because of what we did with this getter and setter up here. By using this setter, we're automatically setting the dataset status, and that dataset status is tied to our CSS right here, which changes the background color for us. So by using this getter setter, we made our code for setting the status really simple, and it just propagates throughout all of our entire application, making sure it propagates our color and everything like we would expect. Now, the final thing I want to do is when we actually mark a tile, I want to change the number here for how many mines are left, because if you've marked a tile, that means you're saying that there is a mine at that location. So I want to remove 1 from this number. And if we unmark something, I want to add 1 to this number. So here, I want to create a new function, which is called list mines left. And this function is just going to be inside this file, list mines left. And all this is going to do is take our board and count up all of the tiles that are essentially marked. So to do that, we can just say marked tiles count is equal to, we're going to take our board and we're going to reduce it down to one single variable. And this is going to be a count variable. and we're also going to have each one of our rows. Inside of here, all we need to do is take our count, and we just want to add to our count the number of tiles that match this filter, and this filter is just going to check to see if this tile is marked. So we can say tile.status is equal to tile statuses.marked. And right now we don't have access to this variable because it's not in the script file. We want to import tile statuses, and that's going to be coming from Minesweeper. So let's make sure up here we also export this, just like that. Now if we save both these files, that should work. And now we have our marked tiles count, as long as we make sure we default this to 0. So our count starts at 0, and each time we just add to our count the number of tiles. If we check the length here, this length variable will give us the number of tiles that match this filter. So it'll just give us the number of tiles that are marked. Then what we can do is we can take our marked tiles count and our number of mines. We just need to subtract the 2. So this is going to give us how many mines are left, the number of mines minus the ones that we've marked as mines. And all we need to do is take our mines left text. We need to set the text content equal to that. If I just spell that correctly, now when we mark a tile, you can see it doesn't make any difference. So clearly we have a problem in our code. Let's just inspect to see if we have an error. And of course we do. Tile status is not defined, and that's because this is tile statuses. That should hopefully fix the problem for us. And now when we mark a tile, you can see it's properly decrementing our number, and when we unmark it, it's increasing the number as we would expect. Also, I'm going to kind of get rid of some of these console logs that we have. They're just kind of cluttering up our console. So there we go, that cleaned those up. And now our game is working as expected, and marking is completely done. So we can come over here and cross that off our to-do list. Now the next step is going to be revealing tiles, which is quite a bit more complex. So let's create that reveal tile function, just like we did with mark tile. So inside of here, let's just come all the way down, export function, reveal tile. I'm going to take in a tile, and then there we go. Inside of here, whenever we click on an element, we just want to reveal the tile of that tile. Pretty self-explanatory. So now we're calling that function every time we left click on a file. And just to make sure it works, let's just console log out our tile. We just inspect over here into our console, we click on a tile, it prints it out, and you can see no matter which one we click on, it's always properly printing out over here, which is perfect. So now, just like we did with mark tile, I want to first check to make sure the tile is eligible. So if the tile.status is not equal to tile_status.hidden, then I just want to return, because we can only reveal tiles that are hidden. If the tile is marked, I don't want to reveal it. And if it's already revealed, obviously I don't want to reveal it. So this can only happen to tiles that are currently hidden. Now the next step in this function is I want to check to see if this is a mine. So if the tile is a mine, then we can just say tile.status is going to be equal to tile_status.mine. We're going to set that as a mine, and we're going to exit out. So if we click on a mine, we're going to set the status to mine. Otherwise, if we don't click on a mine, what we need to do is just take our tile.status and we need to set it to a number. So we can say .number. So now if we click on a tile, you can see that this one was not a mine, which is why it has this number style. If we keep clicking, eventually we're going to run into a mine, which should show up as red. There we go. This was a mine, so it has the red coloring on it. Now the next step is to figure out how many mines are next to a tile, because this tile right here, for example, should have a 1 next to it, because in all of the squares surrounding it, including diagonals, there is 1 mine touching it, so it should have the number 1. While if we find one that doesn't have anything next to it, for example, this tile here has 2 mines next to it, should have the number 2 inside of it, and so on. We need to get all of the nearby elements of a tile that we click on. And to do that, we actually need access to our board. So we're going to pass our board in here to reveal tile so that we can get to the neighboring tiles. And inside of our script, let's just make sure we pass in our board. Just like that. So now we have access to the board, and we can actually get to the nearby tiles. And that's kind of complicated code, so I'm going to create a function called nearby tiles. And it's just going to take in a board and the tile, and we want to get all of the nearby tiles, which we're just going to call adjacent tiles. So this function will get us all of the adjacent tiles for the tile we pass in off of this particular board. We could say function nearby tiles takes in a board and a tile, and inside of here we want to get all the tiles that are adjacent. So we can kind of start this out like we do with a lot of our functions. We're going to have essentially an empty array of tiles, and we're going to add to them before we return. And a really easy way to do this is we know we want to get all the tiles in a 3x3 grid. So we need to get the tile to the left, to the right, to the top bottom, and the top left, top right, bottom left. And all of those are within a 1 -1 to 1 offset. So the tile to the left is -1 to the left, top left is -1 to the left, -1 upward, and so on. So we can just do a simple loop, which is going to have an x offset, which is equal to -1 to start. Make sure I spell that correctly. We're going to say while this x offset is less than or equal to 1, because 1 is our max value, we want to add 1 to our x offset. And we're going to do the exact same thing, but for our y offset. And this is just going to be essentially the y direction as well. And then we can create a tile. So we can say const tile is equal to the element from our board, which is at the x of our current tile. So let's just actually destructure this. We only care about the x and y, so we just destructure it. X plus x offset. And we also want to get the y plus y offset. So this tile is essentially saying, okay, my current x position plus whatever our offset is, which is between -1 and 1, and my current y position plus whatever the y offset is, I want to get the tile at that location. And then we can just add that to our tile array. This may look complete, but there's actually a slight bug with this issue. So if we just inspect our page here, we'll see that bug in just a little bit. If we click on a tile in the middle, it works just fine, no errors. But if we click on a tile in the corner, for example, you're going to see that we get an error, cannot read property 0 of undefined. And that's because right here, our board x plus x offset, or not our x, I'm sorry, our y, is trying to go up -1. It's trying to get a tile that's off of our board. So in order to fix this, what we need to do essentially is use that optional chaining syntax where we have question mark period. So it's saying, okay, if we have an element in this row, then get the element in the y direction. And then we just need to check that if we have a tile, we're going to add it to our list. This is going to fix all of those bugs. So now if we go back to our console and click a tile up in the corner, you can see no matter what we click on in any of these corners, it's always going to work and we're not getting any errors. So now that we have access to our tiles, let's scroll up here a little ways, our adjacent tiles. Let's get the mines that are next to it. So we can say mines is equal to adjacent tiles dot filter. And I want to get any of the tiles that are a mine. And we're just going to use t here. So t dot mine. Anything that returns true there is going to be a mine. And then we can just say if mines dot length equals 0, then we want to do something. Otherwise, if the mines dot length is not equal to 0, so we don't need to worry about anything there, we can just say that we want to take our tile dot element dot text content and set it to our mines dot length. So now, whenever we click on a mine, or an element, I'm sorry, it'll tell us how many mines are nearby, as long as there's more than one. So here, it says there's one mine nearby, and if we check this, you can see there's exactly one mine in that 9x9. For our 2 here, you can see in this 9x9, or 3x3, sorry, these 9 elements, there's 2 mines next to it. Same thing for this 2, there's these 2 elements, and so on. As you can see, there's always at least the number that it says right next to it at all times. And for these ones that are marked as 0, you can see there's no mines next to them. Now, really the final step for this revealing function is to handle when there's no mines, because as you know, in this version of the game, if we just refresh this here and click, when we click on an empty tile, it reveals everything else that is empty as well that's adjacent to that tile we clicked on. And right now, when we click on an empty tile, it just shows up as empty. So we want to implement that logic. So if the mine's length is equal to 0, then what we want to do is essentially recursively call this reveal function for all of the adjacent neighbors. So we can say adjacent tiles.for each. We want to call that reveal tile function. And this reveal tile function takes in the board and the tile. So we can use that fancy bind trick. We can bind null and our board, and then this for each is going to automatically pop in our tile, or each individual adjacent tile, as the third parameter. So now if we click on an empty tile, if I can find one here, you can see it reveals everything next to it. And that's just because we're recursively calling this function over and over again. So if we click on this tile, for example, it reveals all of these adjacent tiles. And for each one of those tiles that's empty, it also reveals all of the adjacent tiles. And it keeps on doing that over and over and over again until there's no more tiles that are empty to reveal. So with that all done, we've essentially completed all of the logic for our game. We can play through the entire game. If I just click on everything, you'll see that eventually we can clear out the entire board, and it looks pretty good overall. But right now there's no lose condition and there's no win condition. For example, if I got to this location without clicking on any of the mines, it should say that I won. And if I got to this location and I clicked on a mine by accident, then it should say that I lost. So what we need to do up here is every time we reveal a tile, I want to check game end. I just want to see, did we win? Did we lose? What is the results? So down here, I can say function check game end. And if we're taking a look at our list, we finished reveal tile and we're on the last step, which is check for win/loss. So I'm going to create 2 variables, const win and const lose. We're going to create a function called check win. and check lose. And we're just going to pass in the board. I want to check our board state to see if we won or lost. And this is logic we're going to put in here. So check win. And we're going to say check lose. These are functions on Minesweeper, so let's actually create them. Make sure that we do this up with all of our other exported functions at the top. It just looks a little bit cleaner that way. Here we go. Export function check win. Takes in our board. And let's just copy this exact thing. And we're going to have for checking our lose condition. So before we write out these functions, let's actually continue down the logic inside of here for what we do if we win or lose. So immediately if we win or if we lose, we want to stop the ability for the user to click on any of these tiles because we don't want them to keep revealing things. And it's actually a little bit difficult to remove the event listeners that are already bound to the tile. So instead, we're going to take advantage of event propagation. I'm going to take our entire board element. I want to add an event listener to that on click. And inside of here, what I want to do is I want to call a function called stop prop. And I want this to be in the capture phase. So essentially what is going to happen is the capture phase occurs before the bubble phase. So our tile elements here, they're using the bubble phase. So their events are going to fire after this click event. And we can call this a stop prop function. So we can say function stop prop. It's going to take in E. And we just say E.stop immediate propagation. Make sure I spell propagation correctly. And call this as a function. And this just stops the event from going further down. So it's never going to get to our individual tiles to call these events for us. And we want to make sure we also do this on context menu as well. And now if we save, no matter if we win or if we lose, we're going to stop the event propagation. So let's just say that we're going to set check win to true. So if we come inside of Minesweeper, check win, we're going to set to true to return that. And now, after we click on our first tile, it won't let us click on any other tiles. And if we right click, it's just going to do a normal right click because it's stopping the propagation from getting all the way down there. And that's just because we're making sure we're automatically returning true here. If we don't do that, we can continue to click and right click all that we want to with no problems. Now, the next thing that I want to do is actually change our text up here depending on if we win or we lose. So if we come in here, we have a class of subtext. We can just get that by coming up here and saying const text. We'll just say message text is equal to document.query selector and is .subtext, just like that. And then down here, we can say if we win, then we want to display some text. And if we lose, we want to display some different text. So we can say message text dot text contents equals you lose. I'm sorry, this should say you win. And down here, it'll say you lose. There we go. So now if inside of our function of check win, we automatically return true and I click, it's going to change to you win. If I put that inside of check lose instead, now it's going to say that you lose. And on top of showing the text you lose, when we lose, I want to reveal the position of all the mines. Because if I click on a mine, you can see it shows all the mine positions. And that's a really nice thing to know. So that way the people can know if they were correct or not. So to do this inside of our script, if we lose, take our board, we want to loop through each row. We want to take our row and loop through for each tile. And all we want to do is we want to say if our tile is a mine, then I want to reveal it. Reveal tile, board, and tile. So now if we just set check lose to true and we click, it's going to reveal all of the tiles to us. One interesting thing to note though, if we just mark a bunch of tiles here real quick, that should be enough. And now we click. You're gonna notice we count, we get 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Okay, that was a bad example, redo. If we mark a bunch of these, hopefully a mine will be underneath of one of them. I just kind of got unlucky with that last one. So we marked all of these. Now when we click, you can see we have 1, 2, 3, 4, 5, 6, 7, which means 3 of the mines are in this yellow area. Well, I want to remove all of the marks so that way we can reveal these tiles. Because as you remember in our Minesweeper code, when we reveal a tile, we only reveal if it's hidden. These marked tiles are unable to be revealed. So first of all, I want to say if the tile.tile status is equal to tile statuses.marked, and this should be status here, then I want to mark the tile. This is essentially just going to say, okay, if the tile is currently marked, mark it again so that it becomes unmarked. So now if I mark a bunch of tiles and I click, it's going to unmark all of those tiles, and if there's a mine behind any of them, it'll reveal it for us. So now that's essentially the logic for the display. The only thing left is to actually make these functions over here for check win and lose do more than just return true and false. So we're going to do check lose first. It's pretty simple. We just need to see, is there a mine that's been revealed? So board.sum, we don't see, is there any? It doesn't matter. We just need at least one. And we can return row.sum for each one of the tiles. And all we need to check is if the tile.status is equal to tilestatus.mine. If we have a single mine revealed, then we lose. So let's check that situation. Let's just keep clicking until we click on a mine. You can see we clicked on it, it said you lose, and revealed all of the mines. That works as expected. So now let's write out our winning code. This is going to be a little bit more complex. Essentially, the way we want our winning code to work is we want to check every single tile, and we want to make sure that every single tile is either revealed as a number, in our case with these numbers here, or it is hidden, or it is marked with a flag. And if the tile is hidden or marked with a flag, we need to make sure that it's a mine. So if every single tile that's not revealed is a mine, then we are a winner. So to do this, we need to, of course, say board.every, because we want to make sure every tile meets this criteria. So if every tile in the row, which means we need to do row.every, and inside of here, we can say tile. And here we can do a return. So first I want to check, is the tile a number, which means it's been revealed. Okay, so t.status is equal to tilestatus.number. That's good. And I want to say, or if the tile is a mine and it meets the following criteria. So if it's a mine and it's either marked or it is hidden. So if the tile.status is equal to hidden, or if the tile.status is equal to marked. So let's just kind of look at this code again real quick. First, we're saying, is the tile a number tile, which means it's been revealed? If so, good, that's perfect. Otherwise, is the tile a mine, and is it either hidden or marked? So this is just saying to make sure that every tile that's either hidden or marked is a mine. If that's the case, then we won. And instead of making me go through and play the entire game to see if I win, I'm just going to reduce the number of mines down to like 3. So hopefully if we click somewhere, we should see a really simple, there's a mine here, here, and here. So this should be counting us as a win, but right now it's not for some reason. So let's inspect to see if we have an error. And of course we do. Reference error T is not defined. So let's come inside of here. This should say tile instead of T. Now, if I come in here and I just click, we can see that there's a tile in these 3 locations. So it says that we win. If we do this one more time and we mark some of these, let's just say we mark these 3 and then reveal the rest of these, you can see again it says we win. So it doesn't matter if they're marked or if they're hidden, as long as the only tiles left unrevealed are mines, then we win. I really hope you enjoyed the process of how I took this large project and broke it down into small, easy to execute tasks that eventually came together to build out the full Minesweeper project. If you did enjoy this and want to see other projects like this, definitely check out my full JavaScript simplified course and use the code early to get 20% off, but that's only good for the next couple days.